Okay, now that we've talked about how to organize the data, we're going to talk about graphing and the shape that it forms. A histogram is an important type of graph that portrays the nature of the distribution. Remember, distribution is what we've just been talking about when we spread the numbers out into classes or groups. A histogram is a bar graph in which the horizontal scale represents classes of data values and the vertical scale represents the frequencies. So, a simple bar graph like you've probably been doing since first grade, but the horizontal has to be numbers of classes, and then of course the vertical is also going to be numbers of frequencies. The heights of the bars correspond to the frequency values, and the bars are drawn adjacent to each other without gaps. This is the biggest difference between a regular bar graph, because adjacent, of course, means that they are touching. So if we look at the graph here on a slide, the heights of black cherry trees, notice that there's a gap in the left-hand corner. The two axes don't actually connect because we don't really care about the trees that are less than 60 feet tall. Evidently, the shortest tree we're looking at is 60 feet or greater, so it jumps in the scale from 0 and just starts at 60. The question on the slide says, how many trees were between 70 and 75 feet? And so all we have to do is find the 70, which evidently is the lower class limit. All of these appear to be lower class limits, starting with a tree of 60 feet and going up. The trees that start with 70, this particular class goes until 75, so we're only counting the height of one bar, go to the top, cross over to the left-hand side till you hit the y-axis, and of course we just see that there are 8 trees that are between 70 and 75 feet tall. We just want you to feel comfortable with reading a basic graph, so we're reviewing some of those skills. A note about the horizontal axis: when you're labeling and when you're looking at graphs, the graph on the previous slide labels the horizontal axis with lower class limits, but there are other ways to label the horizontal axis. You can use midpoints, which we're going to see in just a minute, and those have to be labeled in the middle of the bar, whereas all the rest are just labeled on the edge. Lower class limits we saw on the previous one was labeled on the edge. Class boundaries can be used, labeled on the edge of the bar, and sometimes you just put the class, so you label the entire class and it's going to take up the whole bar, the middle. So let's build a simple histogram just to make sure that you feel comfortable with all different pieces. Use the given frequency distribution to construct a histogram. Use class midpoints on the horizontal scale. So if you look at our data, the first thing, of course, we would need to do is find those midpoints. We have 4 classes, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. If you remember how to find a midpoint, I'm going to write it over here on the left side of the screen. We take the limit, 60 plus 69, and divide that by 2. Remember, you either need to use parentheses or turn it into 2 steps, and that'll give us 64.5. And we can do that for all 4 classes, or we can go back to the data and see that if the first class starts with 60 and the second class starts with 70, if we subtract those, 70 minus 60 gives us 10, which you'll remember is called the width. And so if we come back to the 64.5 that we found and add 10 to get 74.5, and add 10 to get 84.5, and add 10 to get 94.5, we now have the 4 midpoints. So if we're looking at our graph, we already have frequencies on the left-hand side. I didn't leave myself a lot of room, but I'm going to label that frequencies. And remember, frequencies are just counting. And then on the bottom, we're going to label, we have the scores, so you've got the categories. And again, we're going to jump from 0 to 60, that first class. I'm going to put a little lightning bolt on the horizontal axis, which is another way of showing on a graph that you're jumping. You're not using the regular scale. And so then I'm going to put a little tick mark on the horizontal axis, and about a centimeter over, and then another centimeter over, and another centimeter over, and another centimeter over, and label those with our 4 midpoints. So 64.5, you can turn the page sideways if that helps you write it like I'm doing. And then we just go back and draw the bars. So if we look at our chart, the first bar was a frequency of 5. And so you're going to take your 64.5. Remember, it needs to be in the middle. So start a little bit to the left of your tick mark, go up to the 5, which is halfway between the 4 and the 6, over and back down. It does not have to be perfect. Don't use your ruler, but we're getting an estimation. And then for the next bar, the frequency table told us that it was a count of 3. And remember, they've got a touch, so you don't actually have to draw the left-hand side of your bar. Just go up to where it's 3 on the first bar, and then draw across to the right and down. Our third bar is going to have a frequency of 7. So again, start with the right side of the bar that you just drew, and then just take it up to the 7. Again, halfway between 6 and 8, over to the right and down. Notice that each time our label is in the middle of the bar, and then the last one was 8, so we take that right side of the bar, go up to the 8 just a little bit, over to the right and down. You won't actually have to draw histograms in your homework, you'll just be looking at them and recognizing them. But if you can create something, then you can interpret something, and that's why we wanted you to have that little experience there. One last thing with histograms is to remind you that the frequencies can be raw data or they can be relative frequencies. So you've got the title here saying relative frequency histograms. They still have the same shape, horizontal scales, but the vertical side is marked with relative frequencies. Remember, those are percents instead of the actual frequencies, the raw data. And so if you're looking at this histogram, you can see that it is labeled on the bottom with the full class. So the first bar, it says, is 100 to 111. The second bar is 112 to 123. And we see the different heights of the bars. They're all touching. There is a blank space between the 172 and 183, and that makes it really clear that there's no data there. And so that's one of the advantages of bars touching. Our question on the slide says, what percentage of calories are between 124 and 147? If we look back on the histogram, starting with 124, it only goes up to 135. The height of that bar goes up, and if you look at the left, it tells us it's 30%. And so then we have to also add it to the bar next to it that starts at 136 and goes to 147. Go up to the top of that bar and over to the left-hand axis. We find that it's 10%. So to go from 124 all the way up to 147, this is just a reminder that sometimes they're asking you about data in more than one class. So 30% plus 10% would give us an answer of 40%.